We now start with a number of industrial presentations, and the next presentation is from David Rohde, and the title is Why the Shooting in the Dark Method Dominates Recommended System Practice. Thanks.
Hey, hello everybody. So today I'm going to talk about why, despite all the advances we make with our machine learning models, when we really want to know whether they're going to perform or not, we have no choice but just to deploy them and A/B test them. In other words, we're shooting in the dark. I like to make provocative arguments. I'm going to make a bunch. This talk's actually based on a very condensed version of a position paper. I'm not going to get time to defend every provocative statement I make, but if you want to flag me down and say, Dave, I totally disagree with you, by all means do so. That'll be fun, and we can have a coffee or a beer. I want to highlight, before I get started, two very different cultures. So we're all super aware of deep learning and the phenomenal success it's shown in things like ChatGPT and large language models. It's been mentioned in every talk nearly. And apparently we're able to learn 200 billion parameters, no problem. And then at the same time, we've all been very interested in evidence-based medicine, and of course its fundamental tool is the randomized control trial. It might not be obvious what the diagram up here is, but it's a lot of confidence intervals with that black line representing no effect. So if the confidence interval in a meta-analysis of a systematic review sits firmly on one side or the other, you either know your intervention does help or harm. And that's a very typical situation where all the confidence intervals just cross the line, something that's seen all the time in medicine. Now, what's recommended systems more like? I would argue it's A/B testing. It's more like a randomized control trial. It is a randomized control trial. And what have we rolled out in all of our recommended systems? Deep learning pipelines. So, which I support this effort, but we shouldn't try to win arguments by analogy. So what is current practice, which I would say is the shooting in the dark method? Well, we use proxies. Something like collaborative filtering, although increasingly we're also content, perhaps combined together. We advance these forward. We then use attribution. Attribution is more or less saying clicks are not the real value, but we'll map the value back to the clicks. And then this works to build a system, but if we actually want to see if the system works and try to improve it, we end up replacing some of these with a modification and just rolling it out and testing it. And this is, okay, it's not going to animate, but this is shooting in the dark. We really don't know if this is going to work or not. So my position is that shooting in the dark method is actually best practice, and it's not that easy to do better than. Doesn't mean we should try, but we need to be realistic about it. Directly targeting real performance, as measured by A/B testing though, which some people claim to be able to do using methods like RL, I really think it's too ambitious and it's really out of reach. Attribution, which is reweighting clicks with the values, is a fundamentally broken idea. The value doesn't belong to the recommendation, but we probably need to do it anyway. See point 2, why. I like click models, but I don't think we do it all that well, and really, there are still open questions even with click models in doing this well. I also don't believe off-policy estimators, despite the very vigorous academic literature here, work. They don't work on real problems, and in fact, they also don't work on toy problems. I'm going to show this by looking at the likelihood function, which contains all the information. These estimators actually dispose of information. Finally, I like proxy methods because the other methods are weak in terms of the information they contain. And there's also an academic literature on causality. We don't need to worry about it. You can't confound yourself with a recommender system. You're not going to get unobserved confounding on a recommender system unless you confound yourself. So let's try to target A/B test performance and see what it looks like, how that happens. Well, firstly, what is an A/B test? It's a proper population split, and it works at an extremely aggregate level, and we're separating we do it at an aggregate level by saying, here's one policy, here's another, and we only measure the utility in these. It makes a bunch of usually pretty reasonable assumptions, but this only allows us to measure. It doesn't allow us to propose new recommender systems. The disaggregate data looks like this, though. you see items, so the user does things, express interest, we recommend, usually multiple items at once, the user responds, more response, the user then organically does things. So we get this sequence that isn't of the nice form before, where we get learn something, action, etc. And then we sometimes see high-value events. So how would we be able to move between these two worlds? Well, if you're a Bayesian, it's relatively straightforward, at least in theory. We'll see very quickly it's not in practice. Let's firstly write down the likelihood function, which contains the entire information in the sample. I know it's not helpful to flash up a formula like this. This is just an MDP with no assumptions really being made, and an arrow of time, except an arrow of time, but everything else you've sort of already assumed. We can then compute a predictive distribution. So the first formula is conditional on the logs of the data you've actually seen, not the policy that delivers them. Now with some manipulations, we can look at the policy where you deliver them, and at least in theory, deliver optimized utility. But in practice, can we? Actually, we'll see very quickly, you can't. The likelihood function is very thin. I'm going to simplify the problem. I'm going to look only at the second factor, which is the first one that's non-trivial, and the first one conditionally only on an action, and I'm going to make it easier. I will then say I'm only going to look at one action at a time, and I'm only going to look at if there's a click, and I'm going to make it very small, only 1,000 interests and 10,000 actions. Okay, let's say we have 10 to the 12 users, about 100 times the population of Earth, and the best action has a CTR of 2% and the rest is 1%. Well, actually, it's okay now, but let's start looking at some smaller data sets. Say, only, a mega city. You're many orders of magnitude able to be able to do it. Why is this a problem? It's because you're crossing the interest with the action that's being recommended. So what do people actually do? Obviously, we build things and they do something and they're not that bad. Well, we sort of shoot in the dark again because we feed forward not the full cross between the action and the interest, but we sorry, my slides are a little mangled. We feed forward features that have come through the original similarities. And this means that we have a proxy heuristic when we feed forward candidates, we have a proxy heuristic when we do attribution, and then we have proxy heuristic when we feed forward our similarities. And people are ingenious, and sometimes they can make it work, but fundamentally this is a guess, it's shooting in the dark. By the way, deep learning can make this worse by making sequential models that are going to make the interests even more dimensional and even richer. But can we use deep learning? I think there's some hope here, and I'm going to say we should use deep learning, but not to go deep. There are two things we can do. Like deep learning is fundamentally auto-diff, and we can build bespoke click models that can deal with the fact that things like multiple recommendations are delivered at the same time. And it's very standard, and most systems do this. And we can also do Bayesian deep learning, which means we can use a proper probabilistic model for the clicks, but we can also bring to bear the proxies, which, as I said all the way through, are very important, and that's fundamentally because the likelihood function is very flat here. And this doesn't solve everything, it's just doing the click models, but the click model is one of the most interesting things that we can actually model fully, and it contains something we're very interested in, the cross between the interest of the user and the item recommended. Obviously, this was super condensed, and I haven't been able to defend every point, but if you'd like to see a follow-up, I'm doing a webinar next week that you're most welcome to join. Cheers.
Thanks, Davide. And if there are no questions from the audience, I have a curiosity. Online A/B testing is really important from the practical point of view. My question is, why in the community, the RecSys community, but also outside, all algorithmic papers describing machine learning techniques are using the traditional offline evaluation methodologies, and there are no papers using evaluation methodologies which are closest to the A/B testing, like, I don't know, off-policy evaluation and so on. In your opinion?
It's a sociological question, isn't it? I mean, it's hard to write these papers unless you work for a company that owns a recommender system, and then when you submit them, sometimes they're rejected. I mean, they look different, they feel different, they're different priorities. I don't know. I wish I had more time to discuss.
Okay.
All right.
Okay. Thanks
Cheers.
again, the speaker for the presentation.